A 60 kilogram boy jumps off the back of a 3 kilogram skateboard. So let's go ahead and get our objects here. We have a 60 kilogram boy jumps off the back of a skateboard, which is 3 kilograms. And it's moving forward. So he's on the skateboard, they're moving forward at the same velocity. Find the skateboard's velocity immediately after the boy jumps, assuming that the skateboard's initial velocity, so V1, is 4.5 meters per second. That's pretty quick. And the boy's velocity when jumping off the back is 7 meters per second. Okay. The fact that this says back is highlighted, that tells me that V2A, which is the boy, is going to be negative 7 meters per second because that means he is jumping this direction. Relatively speaking, right? He's kind of compared to the skateboard, he's going faster than that, but we're not going to worry about relative velocity right now. So we want to know what is the initial velocity, what is the skateboard's velocity immediately after the boy jumps. Okay, so we want to know V2B. All right, so because they're together initially and then they break apart, I can automatically tell you that this is a perfectly inelastic, an N would help here, hang on. Collision, and it's this specifically the kind that's an explosion, right? Nobody blows up, but it means that they are together initially and then they break apart. All right, so then this has a different equation. So we're initially together, so mass of A plus mass of B times V1 is equal to mass of A V1A plus mass of B V2B. And we want to know what V2B is. So let's subtract this guy from this quantity. So mass of A plus mass of B times V1 minus mass of A V1A. And then I got to get rid of this mass of B. So that whole thing is going to be over the mass of B to get V2B. And again, if you're struggling with any of the algebra, come see me so that we can get that all figured out. All right, so plugging everything in, I should have 60 kilograms plus 3 kilograms times an initial velocity of 4.5 meters per second. And we are going to, let me erase this arrow here. We're going to subtract from that MA, which is 60 kilograms times negative 7 meters per second. So with a minus and a minus, this is going to end up changing both of those to plus. And then my mass of the skateboard is 3 kilograms. So my velocity 2 of the board. Now here's the thing. This guy is going off the back of the board really, really, really fast. 7 meters per second doesn't seem like a whole lot, but it's pretty fast, which means that skateboard to have the same momentum is going to be shooting out from him, under him, really fast rate. So when I do the math for this, I end up with 234.5 meters per second. Not quite a realistic amount, but we're just working on the process. All right, and number 4, 2 equally sized cars. Okay, that makes me suspicious that we might have an elastic collision. So let me, mass of A is equal to mass of B, and we're going to just call it mass. Are heading towards each other with a velocity of 10 meters per second and negative 12 meters per second, respectively. So V1 1A, we said is 10 meters per second. V1B is negative 12. If this is an elastic collision, okay, so it's written right there in the problem, so we don't have to worry about stating what kind it is. It's right there. What is the final velocity of car A if car B is going 10 meters per second after the collision? So V2B is equal to 10 meters per second. And I see right here that this 10 has just switched from object A to object B, which means that this one is going to switch to V2 of object A. So that is going to become negative 12 meters per second. And I can do that because it's perfectly elastic. Well, there is no such thing as perfectly elastic. It's an elastic collision. What's the final velocity of car A if B is going, we got that. It's this one right here. Is there a change in kinetic energy? No. An elastic collision conserves kinetic energy. Okay, an elastic collision conserves kinetic energy, but you're talking about like the kinetic energy before and the total, right? So like KE1 and KE2, or before and after. All right, so that is the conclusion of our second page.